Purpose of this lesson is to see how we can use the quadratic formula to solve quadratic equations. So looking at the slide here, we have the function graph f1 of x equals to x squared minus 6x minus 16. Looking at the graph, what are the solutions or the roots or the x-intercepts? They are x is equal to -2 or x is equal to 0. X is equal to 8. Let's look at this one. All right, we have f1 of x equals to 3 times x squared plus 10x minus 8. So what are the solutions to this? What are the solutions to this quadratic? Okay, we can see one of them pretty well. We see x is clearly -4, but we can't exactly tell what that other solution is. We just know it's between 0 and 1. So how can we find the exact solution for that second x-intercept? This is when we need to solve an equation. Solve for x. So how do we solve for x? Well, we solve for x, or why do we solve for x? We solve for x to determine where the graph of quadratic equations cross the x-axis. And it also determines what values of x make the equation 0. That's why we call them zeros. Because you can't factor all quadratic equations, or at least not easily. So we're going to use the quadratic formula to solve for x. Now, where does the quadratic formula come from? It actually comes from solving this equation, where a, b, and c are integers. Okay, so let's pretend that we want to solve this equation. Not pretend, let's actually solve this equation using the completion of squares. So here's a general quadratic equation. In order to complete the square, we need to make sure that the a value is 1. So we need to divide. We don't want to have any coefficient of x squared, so we'll divide everything by a. Then we move our constant term on the other side by subtracting c over a from each side. And then we're going to take half. We're going to take half of the linear term, the linear coefficient, and square it and add it to both sides. This is called completing the square. Sorry about the sneeze there. Now let's simplify, because now we have a perfect square on the left. All right, and we can simplify on the right. Factor the left side, simplify on the right. Same thing I just said, of course. All right, so now we can take the square root of both sides, because it is a perfect square on the left. And excuse me, that leaves us with this situation. All right, and then finally, let's simplify a little more. Simplify the radicals, moving the b, negative b over to a, moving it to the other side to isolate x. We have actually solved the equation for x, the general equation. So x is equal to negative, or the opposite of whatever b is, plus or minus the square root of a b squared minus 4ac equals 2a. The genius of this is all you need is the values of a, b, and c to figure out what x is. That's the quadratic formula. So let's use it to solve these 3 examples here. Let's say I want to find what is x, so that 3x squared plus 10x minus 8 is equal to 0. First, figure out what my a, b, and c values are. All right, a value is 3, b value is 10, and c value is -8. Substitute those values in the formula like so. Look where the B's are going to go. Look where the A's are going to go. Look where C is going to go. So the 10 is going to replace all the B's. Just wherever you see a B. And then we got some A's. Let's go ahead and replace every A value with 3. And let's replace all the C values with C. And there's another A value we forgot about. All right. So now we got nothing but numbers. Let's simplify. All right. We have this situation. All right. We got 100 plus all this ends up being 96. So 4 times 3 is 12. 8 times 12 is 196. And the negative times, 8 times 12 is 96. And you add 100 to that, you get 196 because these negatives are going to divide out, multiply out. So you end up with just a positive number underneath the radical. So the square root of 196 is 14. And now you got two cases. You got you got negative 10 plus 14 over 6 and negative 10 minus 14 over 6. All right, there's the plus, there's the minus. So if you simplify on the left, you get 2/3 because you get a 4 over 6. 4 over 6 simplifies to 2/3. And the right solution, you end up with a negative 24 over 6, which is just negative 4. And that's how you use the quadratic formula to solve a quadratic equation. All right. So the solutions to 3x squared plus 10x minus 8 are x equals 2/3 and x equals to negative 4. Sometimes we'll also write it like in set notation. The solutions are negative 4 and 2/3. I generally like to put the small solutions on the left and the larger ones. Well, actually, that's what they did. Okay. Now, how do we know that those answers work? All we do, we just substitute them back in the formula. In the equation. If x is 2/3, then we should get a 0 when we put 2/3 back in the formula. And doing the math, you see right here, we're going to get, actually this is going to end up, it's going to be pretty hairy, but if you put this in the calculator, you'll end up with 3 times 4/9. All right, that's going to reduce. And then you got 10 times 2/3. That's going to turn into something. At any rate, you'll see that this ends up being 0. Okay? Same thing on this side. It's a little easier to see it on this side. Because here you can see if 3 times 14 plus 40, subtract 40 minus 8, this ends up being 48. And 48 minus 48 is 0. I believe that's what happens there. Yes. No, it ends up being 32 minus 32. That's what happens, and you get 0. All right. Anyway, it works. You can also check by graphing. If you graph, you'll see that one intercept is at negative 4, and the other one is at the decimal approximation for 2/3. So let's do the same thing with this example. All right, substitute. Well, actually, pick out A, B, and C. All right, substitute, simplify. You end up with this. And so you got 6 over 4 or 4 over 4, which reduces to 3/2 and 1. Or, and let's see, I can't see it because of where my camera is. All right, so let's look at this one. All right. Sometimes you don't always get a neat solution. Notice that in this particular example, you can go back and pause the video if you want to see how all that came about. You end up with a prime number underneath the radical. You can't simplify any further, so that's what your answer is going to look like for this problem. You'll just end up with this expression. That's two numbers, one with the plus case, one with the minus case, and that's the simplest way that you can write it. Okay. So when we have something written like this, then we're talking about two different numbers. There's one, there's the other. So you got two solutions. All these are different ways. And then there's another way that you can write it, like that. So all these are different ways that your answers will show up if you use the quadratic formula. All right, and that's pretty much it. I hope this helped you, and have a good day.